Hello and good morning. I'm Marcela Bragagnolo, a 3D artist, Unreal Engine authorized instructor partner, and a graduate of the Unreal Engine Animation Fellowship. My background is in animation, motion capture, VFX, and also in performing arts. Today, we'll explore how to dress characters for film and performance, with a focus on cloth simulation for animation in Unreal Engine's sequencer. This session is geared toward linear content workflows. Here's what you'll learn today. First, you'll get a comprehensive understanding of cloth simulation options using Marvelous Designer and Unreal Engine. You'll gain hands on experience with two different pipelines for wardrobe integration. The first, using chaos cloth simulation with Metahuman clothing. The second, using geometry cache. We'll compare the strengths and limitations of both workflows in real world production scenarios. You'll learn how to integrate marvelous designer assets with metahuman characters in Unreal. And finally, we'll walk through best practices for using both Chaos Cloth and Geometry Cache workflows. By the end of this session, you'll develop the critical eye needed to choose the optimal pipeline for your project based on technical needs, creative goals, and timeline. Chaos versus Alembic pipeline overview. Let's take a moment to review and compare the two pipelines shown here. On the left, we have the Chaos Cloth pipeline, and on the right, the Alembic or Geometry Cache pipeline. Starting with the Chaos Cloth pipeline, this workflow is real time and interactive, ideal for virtual production, XR, or any scenario where immediate visual feedback is critical. We begin in Unreal Engine by creating a metahuman without animation. From there, we export the skeletal mesh to Marvelous Designer, where we create and fit the garment. It's important to ensure the garment is properly adjusted to the metahuman's proportions and optimized for Unreal Engine use. Once the garment is ready, we export it back into Unreal, traditionally as USD file to transfer all fabric properties. Then we convert it into a chaos cloth asset where we assign weight maps, define the physics in a data flow. Finally, we assemble it as a wardrobe item using the MetaHuman outfit pipeline. The big advantage of this pipeline is flexibility. The garment will adapt to any animation you apply later. No need to rebake or re export every time you change motion. Now let's take a look at the Alembic pipeline, also known as the geometry cache workflow. Unlike Chaos Cloth, this approach is pre-baked, meaning the simulation is calculated ahead of time. Alembic is a file format used to store baked animation data, including complex simulations like cloth, hair, or geometry deformations. When we say an alembic animation, we mean that the movement of every vertex on the mesh is pre-calculated and saved. This means no physics or simulations will run in real time. Everything is already baked into the file. The Alembic file plays back like a pre-recorded animation, so while it can't adapt to new motion, it guarantees predictable and high-quality results. This method is ideal when you need predictable, high fidelity cloth behavior that stays exactly the same every time you render. We start by animating the metahuman, either inside Unreal Engine or externally, and exporting the animation. Next, in Marvelous Designer, we simulate the garment animation based on that exact movement. Once the simulation is complete, we export the garment as an Alembic file. Back in Unreal Engine, we assemble the MetaHuman and Alembic cache together in a level sequence. Then finally, we refine and render, adjusting the timing, position, tweaking fabric materials, or MetaHuman texture masks in Unreal Engine Sequencer or Material Editor. This pipeline is great when consistency is key, for example, in feature animation or high end cinematics, where every frame needs to be locked and predictable in front of the camera. Before we dive in, let's go over the prerequisites for this tutorial. This session is built using Unreal Engine 5.6, and everything should work smoothly on version 5.6 or higher. First, open your Epic Games launcher, go to the Fab tab, and make sure you have the necessary plugins installed in your library. You'll need the Clo Marvelous Designer plugin. This is our bridge to move garments and metahumans in and out of Marvelous Designer and Unreal Engine. Once the plugins are in your library and added to your project, go ahead and open your Unreal project. Inside the Unreal Engine editor, go to Edit Greater Than Plugins and make sure the following plugins are enabled: Metahumans, Clo Marvelous Designer, Chaos Cloth, Geometry Cache. There's a screenshot in the slide deck that shows all of these plugins as a visual reference. After enabling them, Unreal will prompt you to restart the engine. Make sure to do so. This step ensures all systems initialize correctly, and the MetaHuman Creator interface becomes available inside the editor. Now, keep in mind, creating metahumans in UE 5.6 is slightly different from previous versions. If you've been following along with my earlier sessions, you should already have your metahuman and garment prepared and ready to go. Let's begin with the Chaos Cloth pipeline, which is a real-time simulation workflow. We start by creating our metahuman inside Unreal Engine. With Unreal Engine 5.6, the process is much more streamlined. We can now export the entire metahuman, both the head and the body combined, directly to Marvelous Designer with just the click of a button using the Clo plugin. In Marvelous Designer, we'll import this metahuman and bring in the pre-fitted garment that you've already created for your character. Now, when exporting the garment back into Unreal, you have two options: export it as a USD file, or use the Kielo plugin to preserve fabric properties and simulation settings. Back in Unreal Engine, we'll create a Chaos Cloth asset and begin configuring it using the Dataflow system. This is where you define physics settings, simulation constraints, and refine the cloth behavior to suit your animation needs. Once the data flow setup is complete, we'll assemble the garment as a wardrobe asset using the MetaHuman outfit pipeline, integrating it directly into your MetaHuman character. Why use Chaos Cloth? Chaos Cloth gives you interactive, real-time feedback, which is essential for virtual production, XR experiences, performance capture sessions, or any scenario where fast iteration is important. And best of all, once the cloth is set up as a wardrobe asset, you can reuse it across different animations. There's no need to simulate again for every new motion, unlike the Alembic pipeline. So if you're working under tight deadlines, this can be a great time-saving solution. Preparing MetaHuman and Garment Chaos Cloth Pipeline. All right, let's walk through the process of preparing your MetaHuman and Garment for the Chaos Cloth Pipeline. Step 1, export the MetaHuman as combined skeletal mesh. Start by opening the MetaHuman character editor in Unreal Engine. In the top left panel, locate the MetaHuman character tab. Right-click it to open the dropdown and select Export Combined Skeletal Mesh. This will create a version of your MetaHuman where head and body are merged, and save it to your content drawer. Step 2, create a reference pose. Next, double-click the skeletal mesh to open it in the skeletal mesh editor. At the top, go to Create Asset, Create Animation, Create Reference Pose. If a reference pose already exists in your project, you can skip this and just click Current Pose. Step 3, enable Clo Live Sync. Now, at the top of your Unreal viewport, switch selection mode to Clo Live Sync mode. At this point, make sure Marvelous Designer is open in the background. Open a new blank project and have your garment file ready on your computer. When the Clo Live Sync button turns green, it means Unreal and Marvelous are successfully connected. Step 4, send Metahuman to Marvelous Designer. Back in Unreal, select your combined skeletal mesh pose asset. Open it, click the Clo Live Sync icon, and choose Send as Live Sync Arrow Skeletal Mesh. In the export dialog that appears, confirm the export. In Marvelous Designer, another window will appear. This is where you configure Import as Avatar, enable fitting suit and arrangement points, choose centimeters and DAS measurement units. Set y-axis up, click Import. Now, in Marvelous Designer, you should see your MetaHuman avatar appear in the 3D viewport. Step 5, load and fit your garment. Next, load your garment. Go to File arrow Open and choose either a project or garment file, depending on how you saved it. Choose ADD Garment in the pop window in Marvelous. Once it's loaded, hit Simulate to fit it properly to the avatar. Step 6, optimize the garment for simulation. Here are some key optimization tips. Particle distance controls garment resolution. Use lower values, e.g. 5 for detailed, flexible parts. Use higher values, e.g. 20, for rigid or static areas. Aim to keep the garment under 15,000 triangles for smoother performance in Unreal. Avoid areas with pinching or heavy folds. These require custom skin weights or proxy deformers. Maintain good spacing between overlapping layers to improve cloth skinning and wrapping. Avoid thin straps, belts, or attachments that twist or cause extreme bending. Prefer wider accessories. They behave better in cloth simulation. Convert top stitch details into textures, otherwise they import as full geometry, increasing polygon count. Double check fabric properties. These will be passed into Unreal's Dataflow. Keep the garment as a single, clean mesh. Weld vertices to avoid unconstrained motion. For complex garments, consider simplifying in Blender or Maya to optimize geometry before import. Final step, simulate pack UVs. Once everything is ready, run a final simulation to test fit and behavior. Open the UV editor and pack the UVS in the material window. Your garment is now ready for import and chaos cloth configuration in Unreal. Now that your garment is simulated and optimized in Marvelous Designer, it's time to bring it into Unreal Engine. Option 1, using the Clo plugin, Live Sync. First, make sure that Marvelous Designer and Unreal are opening simultaneously. You are in Clo mode inside the Unreal viewport, and the Clo Live Sync light is green. Also, make sure your MetaHuman is placed in the scene, ideally at location 000. This ensures the garment will appear correctly aligned on the character. With your garment ready, go to the Clo Live Sync panel and click Update. You'll see a progress bar appear in the lower right corner of the screen. Be patient and monitor it. Once the bar completes, the garment will appear on your MetaHuman, but it's not yet saved. So now click Save as Cloth. When you do, the garment will disappear from the MetaHuman. And that's normal. It has now been saved in your content drawer in the folder you specified. Project organization. Before saving, always create a dedicated folder for your clothing assets to keep your project organized. Also, take time to rename the imported assets because they usually come in as untitled. You'll typically see two meshes, one for rendering, one for simulation. At this point, your garment is successfully imported and ready to be configured using the Chaos Cloth data flow. What if the Clo plugin doesn't work? Since Unreal 5.4, there have been cases where the Clo plugin is not active. usually when either Unreal or Marvelous Designer updates before the plugin is patched. Here's what to check. Make sure you don't have duplicate versions of the Clo plugin installed. Delete older versions and keep only the latest one. If the Clo plugin isn't working, here's the alternative method, using a USD export from Marvelous Designer. 1. In Marvelous Designer, go to File, Export, USD. 2. In the Export dialog, choose USDA format. Save the file and textures to your computer. In the pop-up settings, uncheck Avatar. Choose Single Object. Select centimeters, DAS measurements, and Y-axis up. Enable Include Simulation, Unified UV Coordinates. Wrap Textures 3, click OK. Marvelous Designer will export in your computer a USDA file, a folder with all associated texture maps. Now, back in Unreal, creating a cloth asset from USD. 1. Go to the content drawer. 2. Right-click, Physics, Cloth Asset. 3. Open the new cloth asset by double-clicking it. 4. It will open a Dataflow editor. Click the first node. 5. In the Details panel, set the USD source file. 6. Click USD import, then use the file browser to locate the USDA file you exported. Once selected, Unreal will load the garment into the data flow, ready to be configured for simulation. Now, let's go through the 4 main stages of the Chaos Cloth data flow inside Unreal Engine. Step 1. Import the render mesh. The first step is to bring in the render mesh. This is the visible geometry of your garment. Once imported, select the Metahuman skeletal mesh your garment will be attached to. You'll see the garment properly fitted to your character. Step 2. Bind the skeletal mesh. Next, we bind the garment to the metahuman using a process called skinning. In the second tab of the data flow, you'll set the skeletal mesh. Click Transfer Skin Weight. In the Details panel, choose your metahuman skeletal mesh as the target. In the preview window, you can test by applying an animation. You'll see your garment move with the character. This step ensures the cloth moves with your character before fabric simulation is even applied. Step 3. Set up the sim mesh and paint the max distance. All right, now it's time to tell Unreal how the fabric should move during the simulation. We're going to paint a max distance map. And this is basically a guide that tells Unreal, hey, this part of the garment can move around and float, and this part should stay locked close to the body. Here's how it works. White areas on the map equals fabric moves freely, great for loose sleeves, skirts, coats. Black areas equals fabric stays snug, perfect for collars, cuffs, waistbands. A smooth gradient between those two is what gives you a nice natural drape. You can do the painting in either the 2D pattern view or directly in the 3D viewport. Both work. Just make sure to check the result in 3D, especially if you painted in 2D. Now, before you start painting, look over to the left panel. That's where you'll find all the brush settings like brush size, fall off, strength, and the actual max distance value you want to apply. Set those based on the kind of garment you're working with. For example, a flowy fabric will need a higher distance than a structured one. Take your time to test and tweak these until it feels right. Then, when you're done painting, switch to smooth mode and go over the edges. This blends out the transitions between black and white and helps avoid simulation artifacts or popping. Last step here, over on the right side of your viewport, check the Node Details panel. There are a few more advanced settings there that can help fine tune how your sim mesh behaves. It's worth reviewing them, especially if your garment isn't responding quite the way you want. And once you're happy with the whole setup, go ahead and click Accept. On to the next step. Step 3. Now that we've finished painting the max distance, let's take a look at the simulation settings. You're going to notice that Unreal Engine automatically brings in a lot of the fabric properties from Marvelous Designer. That's super helpful, but it doesn't always look the same right away. So, what do? You click into the simulation settings, and you'll see that every piece of the garment has its own fabric settings. These are basically the same categories that you had over in Marvelous Designer, but they were not imported with 100% fidelity right out of the box. I placed it on one side of your screen, Marvelous Designer, and on the other side, Unreal, side by side. That way, you can literally compare the properties line by line because, and this is important, sometimes a fabric behaves beautifully in Marvelous Designer, but then when you bring it into Unreal, it just doesn't look or move the same right out of the box. That's when you start adjusting the values. Think of this process like retuning a musical instrument that was moved from one room to another. The foundation is there, but you've got to tweak it for the space it's in. This part is crucial. This is where realism comes from. If your garment is going to be seen up close to the camera, or if it has a lot of movement, like a skirt twirling, you'll need to invest the time here to dial everything in. So don't rush through it. Be patient. This is a learning curve, yes, but the payoff is huge. Also, keep in mind, as new versions of Unreal Engine come out, like with 5.6 now, the Dataflow system keeps evolving. You might notice more nodes are available each time. For example, some older nodes like Simulation Config might now be replaced or extended by new nodes like Simulation Self Collision. So always take a minute to explore. Right click in the data flow and see what new options are available to you. And please read the documentation. I know it's not fun, but it's worth it, especially if you're dealing with complex cloth or layers or interactive scenes where garments need to behave precisely. The closer the garment is to the camera and the more it moves or interacts, the more tweaking and optimizing you'll need to do here. And remember, a garment that works beautifully on a solo metahuman might behave totally differently if that character starts interacting with others or performing in a choreographed scene. There's no one size fits all recipe for the data flow. You have to customize it for each project, for each type of fabric, and for each scene setup. Step 4. Set the physical asset collision setup. Now, we give the garment collision data so it can interact with the character body and avoid penetration. Click the Set Physical Asset node and in the Details panel, assign your MetaHumans physics asset from the drop down. Then preview. The garment should now react to the body without clipping. If it still penetrates, we'll troubleshoot it later. Final step, level of detail LOD collection. Finally, set up your LOD collection. If your character appears close to the camera, use LOD0. For background characters, set up lower LODs to improve performance. In the collection node, add or remove pins for different LODs. For this tutorial, we'll use only LOD0 and disconnect the others. I've also added a link in the slides to a great talk from Unreal Fest Orlando that walks through this process with great clarity. This wraps up the full setup of the Chaos Cloth data flow. But we're not done yet because starting with Unreal Engine 5.6, the workflow has changed. And this is really important. What we used to do In older versions, we just take the Chaos Cloth asset and parent it to the metahuman's body using a blueprint, but that no longer gives you the best results. What we do now, in 5.6 and above, to get proper simulation and wardrobe integration, we need to create a metahuman wardrobe using two more assets: an outfit asset, a metahuman wardrobe asset. Let's walk through it. Step 1: create the outfit asset. 1. In the content drawer, right click and search for Outfit Asset. 2. Create it, and now you'll see a new Outfit Asset icon in your content browser. 3. Double click to open it, and you'll see a small data flow, a panel for adding source assets. 4. In the Source Asset field, click the drop down or arrow. Select the Chaos Cloth asset we just created. 5. In the Source Body Parts field, select the metahuman skeletal mesh that your garment was fitted to. That's it. Your outfit asset is now connected to both the cloth simulation and the metahuman. Step 2: create the metahuman wardrobe asset. 1. Again, in the content drawer, right click and search for Metahuman Wardrobe. 2. Create it and double click to open. 3. Inside the wardrobe editor, you'll see a drop down under Principal Asset. Click it and choose the outfit asset you just made. 4. Now, for the pipeline and editor pipeline, select Metahuman Outfit and Metahuman Outfit Editor Pipeline. 5. Final step, and this one is super helpful. Take a screenshot of your garment and drag it into the preview box at the top. This will help you identify your wardrobe items visually, especially when you have multiple outfits in the same project. Also, don't forget to name your wardrobe clearly: dressing the metahuman with the wardrobe. All right, now we're finally ready to dress our metahuman. Let's go back to the content drawer, and this is important. You want to look for the metahuman character editor, not the blueprint. So find your metahuman and double click on the metahuman character editor to open it. You'll probably see a little message pop up that says, "The asset you're editing is rigged. Present and material selections and modeling operations require that the rig is deleted to unlock editing." No problem, just click Remove Rig. What that does is temporarily strip the rig so you can assign a new outfit without Unreal fighting back. Now, it's time to add the wardrobe. Go to the hair and clothing section in the left panel. Scroll all the way down until you see Outfit Clothing. Click the little arrow to open the dropdown, and you'll see a box labeled All Assets. From the content drawer, grab the wardrobe asset you just created and drag it into that box. You'll see right away in the viewport, your metahuman is now dressed with your Chaos Cloth wardrobe. Check mark. Once you're happy with how it looks, it's time to rebuild the rig. Just go back and click Create Full Rig. This will rebuild the metahuman skeleton, now with the clothing correctly attached and simulated. But here's something that always confuses people: your metahuman blueprint won't appear in the content drawer until you click Assemble. So once the rig is done, go ahead and hit Assemble. Now, you'll see the metahuman blueprint show up in your metahuman folder, and you're ready to use this character in any sequence or cinematic. Refinements and troubleshooting. All right, so we've dressed our metahuman and everything looks great, or at least we hope it does. But if it's not perfect, don't worry. Let's talk about what can go wrong and how to fix it. Issue 1: Metahuman skin clipping through the garment. This happens sometimes, especially around elbows, hips, or other tight areas. There are two main solutions you can try. Option 1: use a texture mask on the metahuman. We'll go deeper into this in the next session, but here's the idea. You create a mask texture for your metahuman, and everything under the clothes becomes transparent. So even if the skin is clipping through, no one will see it. This doesn't change the simulation and it keeps the body proportions consistent. You might lose a little volume visually, but it's way less noticeable than deformation from the next option. Option 2, adjust the physics capsules. This requires a bit more work. You create a duplicate of your MetaHumans physics asset, and then you go in and resize or reposition the collision capsules to give the cloth a bit more clearance around the body. Then you go into the MetaHuman blueprint and replace the original physics asset with your modified version. This can work well, but keep in mind if you expand those capsules too much, you might start to see weird deformation or unnatural volume during movement. That's why I usually recommend the mask method first, especially for cinematic work. Issue 2, inconsistent simulation in sequencer. Sometimes your simulation looks great in the editor, but then acts weird or inconsistent once you drop your metahuman into sequencer. The fix? Cache the simulation in sequencer. That locks in the cloth behavior and makes sure it's consistent every time you play or render. Working with multiple garment layers. Now, if you're working with multiple layers of clothing, like jackets over shirts or skirts with belts, then yes, the data flow gets more complex. You'll need to add separate nodes for each layer. Carefully organize the layering order. Assign different simulation properties to avoid clipping or collision issues. It takes more patience, more testing, and definitely a steeper learning curve. But yes, layered garments are totally possible with this workflow. Just take your time, explore the available nodes, and tweak the values in the details panel. Trial and error is your best friend here. Why use chaos cloth? Let's quickly remind ourselves why we're doing all this. Chaos Cloth gives you real time feedback. You see results instantly, even during animation playback. Faster iteration, you can make creative decisions on the fly right in the engine. Lightweight file structure, fewer storage demands, and faster project load times. Dynamic interaction, perfect for performance capture or motion capture sessions where the clothes need to respond to unexpected movement or physical forces. Limitations of chaos cloth. But like everything, it's not perfect. Can get unstable with heavy, multi layered garments. Harder to get repeatable, frame accurate simulations, especially if you don't cache. Subtle simulation changes can happen between playbacks. And yes, there's a learning curve, especially around data flow. But once you master it, it opens up a whole world of flexibility for real time projects. Let's take a short break and then we'll come back and dive into the Alembic pipeline, which is a more controlled and but also more rigid workflow. Unreal Engine geometry cache pipeline. All right, welcome back. This is the second part of our session, and now we're diving into a different pipeline, one that uses Alembic files exported from Marvelous Designer. This is known as the Geometry Cache Animation Pipeline. So, what's different? Well, unlike the Chaos Cloth pipeline, where simulation is real time inside Unreal, this approach is more pre baked and locked. Here's how it works. 1. First, we start by animating our metahuman right inside Sequencer in Unreal Engine. 2. Once the animation is ready, we export the MetaHuman's animation to Marvelous Designer. 3. In Marvelous, we then create a cloth simulation that matches that exact movement. So the garment is animated directly in Marvelous Designer, not in Unreal. 4. After that, we export the animated garment back to Unreal using Clo plugin or Alembic format export. And finally, 5. Inside Unreal, we go back to the sequencer and we assemble the scene using the metahuman animation, the animated Alembic garment, and the geometry cache component to play back the baked simulation. This method gives you super precise results. The garment behaves exactly the same every time you render it. That's why this pipeline is often used in feature animation, pre rendered cinematics, and any case where consistency and high visual fidelity are top priorities. It's not real time or dynamic, but it's predictable, controllable, and gives you that perfect simulation every time. All right, now we're going to start the Alembic pipeline, and the very first step is exporting an animation from Unreal Engine. But before we jump into that, there's one thing you absolutely need to have in place. Make sure the first frame of your animation is in a neutral pose, something like an A pose or T pose. Why? Because that's the pose your garment needs to fit properly when it goes into Marvelous Designer. If you try to fit the garment while the metahuman is already moving or the arms are flying around, you're going to have problems, especially if your sleeves are long or the clothing is complex. Oh, and quick tip here, if your garment has long sleeves, by default, metahumans come with elbows slightly bent, so feel free to straighten them out. It will help. So, step by step: one, create a new level sequence. Two, drop your metahuman into the scene, or better yet, use the combined skeletal mesh if your garment has neck or collar details. Three, add the metahuman to the sequencer. Four, add your animation. Now, here's something to pay attention to. If your animation starts in an A pose or T pose, you're good to go, move on. But if it doesn't, you're going to need to manually insert that pose at frame 0 so the simulation starts cleanly. So here's how you handle that. Play the animation and stop on a neutral pose, maybe around frame 20. Set a keyframe there. Then use Control Rig to pose your metahuman in A or T pose at frame 0. This way, the garment can be fitted properly in frame 0, and it'll blend smoothly into the animation. You do not want your character jumping suddenly from T pose to a running motion. That's going to mess up the simulation. Next step is to bake all to control rig. Just right click on the skeletal mesh track, choose Bake to Control Rig, then select the MetaHuman Control Rig, click Create, and let Unreal bake it out. Once it's baked, you'll see all those keyframes show up in the Control Rig track. Now delete everything from first frame up to the start of the actual animation. Keep only the first frame with the neutral pose. This creates a nice, smooth transition from your fitting pose into the motion and gives Marvelous Designer exactly what it needs. Now we're ready to export the animation. Right click on the metahuman body in the sequencer. Select Bake to Animation Sequence. Choose where to save it, give it a name, and make sure your project folders are tidy and organized. All right, we've got the animation baked. Let's move on to sending it to Marvelous Designer. You'll need to keep both Unreal Engine and Marvelous Designer open at the same time. Unreal should be in ClowLive Sync mode. Open the animation level sequence you just created from the content drawer. Double click on it. It's going to open in the animation editor. Now make sure you're using the combined metahuman mesh if you can. If you're using just the body mesh, just know that the process volume can slightly affect the animation. So be aware of that. Then go up to the toolbar and hit the Clo Live Sync icon. From the drop-down, choose Export as Live Sync, Skeletal Mesh. A pop-up will show up. Go ahead and hit Export. Usually the default settings are fine here. Wait a few seconds and then boom, your MetaHuman animation will show up in Marvelous Designer. So by now, you should see that your animation has been successfully transferred into Marvelous Designer. Go ahead, open the animation window, adjust start, and end frame, and hit play. Just preview the motion and make sure everything came through smoothly. It's always exciting to see the metahuman finally moving inside MD. Now, what we just did was method 1, using the Clo plugin and Live Sync. But what if the plugin's not working? That happens sometimes. There are occasional gaps. Maybe a new version of Unreal or Marvelous Designer just came out and the plugin hasn't been updated yet. Or maybe you're bringing a garment from another DCC software and Live Sync isn't part of your workflow. No worries. We have a second method that works in any case. Method 2, exporting animation as FBX. So here's how it goes. 1, go to the content drawer in Unreal. 2, find the animation sequence you just created. 3, right click on it, go to Asset Actions, Export. 4, a window will pop up asking where you want to save the file. Pick a location on your computer. Once you choose the location, Unreal will show the FBX export settings window. No need to change much here. The default settings usually work just fine. Just hit export and Unreal will create an FBX version of your animated metahuman. Now let's go over to Marvelous Designer. Inside Marvelous Designer, do the following. 1, go to File arrow import arrow FBX. 2, select the FBX animation you just exported from Unreal. 3, a settings window will pop up. This part is important. Here's what to select. Open as avatar. Check. Auto create fitting suit. Choose object join animation. Enable automatically add arrangement points. For scale, DAZ plus centimeters, set y-axis up. And finally, uncheck Align Bottom to Ground. Once all that's set, click OK, and Marvelous Designer will import your animated metahuman as an avatar, ready to simulate your garment. And just like that, you're all set up. Whether you're using the live sync or the FBX method, your animation is now inside Marvelous Designer. Coming up next, we'll go over running the simulation, exporting the Alembic ABC file, and bringing it back into Unreal. Simulating and exporting animated garment in Marvelous Designer. All right, let's keep moving forward. Now that your MetaHuman animation is in Marvelous Designer, let's get the garment simulated. First thing, go ahead and open the animation window if it's not already open and make sure you're on the first frame. Now go ahead and bring in your garment. You've already got this garment prepared with proper topology, just like we did in the chaos pipeline. So refer back to those steps if you need a refresher. In Marvelous Designer, go to File arrow add garment or add project if you saved it as a full project. Position the garment carefully around the metahuman in the first frame. Hit the simulation button, that little arrow at the top left of the 3D viewport. Do not scrub the timeline yet. Don't move anything until we record the first garment animation, tagging garment parts to the avatar. Before we animate, we need to tag parts of the garment to the avatar. This keeps things like shoulders, waistbands, or hats from sliding off during movement. Here's how you do it. 1, in the 3D viewport, look for the tag window. 2, from the drop-down, choose Tag to Avatar. 3, now go carefully. The first click is on the garment piece you want to tag. The second click is where the garment turns transparent. That's how you tag it to the avatar. This will glue those parts in place during the animation, adjusting fabric behavior. If something still feels a little loose, you can tweak other fabric behaviors. For example, I sometimes select the waistband and adjust the shrinkage, weft property to help it stay in place. Also, if you're working with multiple garment layers on, you'll want to assign garment layers. And we're only using one garment in this tutorial, but just so you know, Layer 0 is for clothes closest to the body. Layer 1 goes on top of that, and so on. If you suspect your garment is too close to the skin, you can bump the layer from 0 to 1. It helps reduce clipping in Unreal. Optimize before you animate. Just like we did in the chaos pipeline, repeat your optimization steps. Check your particle distance. Keep your vertex count low. Convert top stitching to textures if possible, because every top stitch saved as OBJ adds a extra geometry. Also check the avatar's collision settings. Select the avatar, look at the properties panel, play with values like skin offset, static friction, kinetic friction. Increasing offset is especially helpful if the garment is sticking too closely to the skin. And last but not least, double check your fabric properties. This is your last chance to dial in the look and feel before animation. Time to animate. Let's animate the cloth. Before doing anything, go to the animation window and check your FPS settings. If you need to change the frames per second to match Unreal's sequencer, first check preserve frames. Then change the FPS setting, or else your animation length won't line up correctly in sequencer. For simulation quality, I usually choose animation is stable. That gives you 5 iterations per frame. But if the motion is complex, like a dance, sometimes that's not enough. In those cases, I bump it to 6, which changes the simulation mode to custom. More iterations equals better results, but also longer sim time. Now, when you hit record, you'll see a new layer called Garment Layer appear in the timeline. While it's recording, monitor the simulation carefully. If something doesn't look right, just stop it, fix the issue, and simulate again, pressing the Simulate button in the top left of the 3D viewport. When you hit record again, Marvelous will create another garment layer. So if you've created multiple layers, you need to merge them before exporting. 1. Shift select all the usable garment layers. 2. Right click, choose Merge Layers. Marvelous Designer only supports exporting one garment animation layer, so this step is essential. And there you go. Your garment is now animated. And next up, we're going to export it as an alembic.abc file and bring it back into Unreal. Again, you can use the Clo Live Sync plugin or do it manually. Exporting the animated garment to Unreal Engine, Alembic workflow. All right, let's finish this Alembic pipeline by bringing your animated garment back into Unreal Engine. There are 2 ways to do this. Method 1, using the Clo plugin, Live Sync. So first, if you have access to the Clo plugin, this is the most seamless option. Make sure you have both Marvelous Designer and Unreal Engine open and the Unreal project is in Clo mode. 1. In Unreal, go to Window Live Sync. 2. Make sure the Live Sync connection status is green. That means Unreal and Marvelous are communicating properly. 3. Then click Update. You'll see a blue progress bar in the bottom right corner of Unreal. Don't do anything else yet. Wait until that bar fills all the way up. Until that's done, your animated garment won't show up in the viewport. Once it finishes, go ahead and press Save. Clo plugin Save Settings. A pop-up window will appear with several export options. Here's what to select. Only save the garment, not the avatar. Include as a single object. Choose thin or thick based on your fabric. Totally depends on your look and project needs. Unified UV coordinates. Include cache animation. And choose translucent. The masked options is in case you're using masked materials. After that, click Save again. Your garment will disappear from the viewport. That's normal. It's now saved to your content drawer as a geometry cache. Make sure to save it in a dedicated folder. I recommend organizing all your Alembic/geometry cache clothing separately. Method 2. Exporting manually as alembic.abc file. Now, if you don't have access to the Clo plugin, here's the alternative method. 1. In Marvelous Designer, go to File, Export, alembic.abc. Alembic Export Settings, Marvelous. When the export settings window opens, make sure to choose Alembic file type Ogawa, weld mesh, thin or thick, again depending on your fabric needs, unified UV coordinates, then choose where to save it on your computer. Importing the Alembic file into Unreal. Back in Unreal Engine, here's what you do. 1. Create a folder in your content drawer. Keep your cache files organized. 1. Drag and drop the .abc file from your computer into the folder. 2. When the import dialog appears, set the import type to geometry cache. I usually pick Autodesk 3ds Max or Maya preset. That fixes the 90-degree rotation in the x-axis. Click import and you're done. Now your animated garment is ready to be used in the sequencer alongside your animated metahuman. Addressing the metahuman in sequencer and final refinements. All right, we're at the final stretch of the Alembic pipeline. Now it's time to dress your metahuman in sequencer using the animated garment you just brought in from Marvelous Designer. Step 1. Position the garment in the scene. First, drop your Alembic garment into the viewport or outliner. Now go to your MetaHumans details panel and copy the location values, all three, X, Y, and Z. Then go to your garment's details panel and paste those values into the transform location. This will snap the garment into the exact same position as the metahuman. Boom, your metahuman is now dressed. Step 2, add to sequencer. Now, create or open your level sequence and make sure your metahuman is already in it. Then, 1. Select the garment in the viewport or outliner. 2. In the sequencer, click plus track arrow, add actor arrow, selected actor. Now your garment appears in sequencer as a new track. Right click on the garment track, go to add track, geometry cache. This attaches the animated Alembic sequence. Go ahead and hit play. Is it perfect? Maybe yes, maybe not. Step 3, fixing common issues. Sometimes the geometry cache comes in with a one frame offset, which causes things to look off. Here's how to fix that. 1. Right click on the geometry cache track. 2. Go to properties. 3. Adjust the start frame, set it to 0, -1, or -2, and preview which one syncs best. Now, if you're seeing clipping through the garment, there are two things you can do. Option 1, mask the metahuman's skin texture. I'll show this in more detail in the next session, but here's a quick summary. Duplicate the metahuman skin texture. Create a black and white mask. White equals visible skin. Black equals hidden under the garment. Apply this masked texture to a metahuman duplicated material and create a child blueprint metahuman instead. So your original metahuman is untouched. You'll need to replace the metahuman in sequencer. This makes the clipped areas transparent so nothing shows through. Option 2, add a transform track to the garment. You can also nudge the garment forward just slightly if needed. 1. Right-click on the garment's track. 2. Add a transform track. Third, keyframe subtle position adjustments after you've locked your cameras. Why after the cameras? Because you only need to fix what the camera sees. No need to reposition the entire garment globally. Why Alembic geometry cache shines. This method gives you identical cloth behavior across shots. No simulation variation between takes, cinematic quality wrinkles, draping, and motion. Great support for complex or layered costumes, intricate material blending, pockets, attachments, all handled beautifully. Marvelous Designer's layering system is easier out of the box for complex garments compared to building the layers collisions through Dataflow in Chaos Cloth. Limitations of the Alembic workflow. Now, there are trade offs. It's not interactive, there's no real time response. Files are heavy, they store animation per vertex, per frame. Workflow can be slow, especially with long or complex motion. You'll need a solid storage pipeline, and it's not ideal for rapid iteration. You have to be careful during motion capture. What actors need to avoid touching their bodies. There has to be space for cloth simulation between the body and limbs. Sometimes simulations don't align perfectly with every frame, so you might need to add transform tracks, or mask the metahuman skin as we mentioned earlier, but when it works, it really looks great. The visual quality is top notch, especially for close ups, and it's a go to solution for feature animation and cinematic work. All right, let's pause here. In the next session, we'll look deeper into texturing masks and ways to refine both pipelines based on your project's needs. Okay, now it's time to make a decision. Which pipeline should you use? Let's break it down. Choose Alembic when your project is an animated film, music video, or pre rendered cinematic. Character motion is fixed, choreographed, and not changing. You have time to run cloth simulations per animation. You want maximum visual fidelity, especially for locked camera angles and predictable shots. Alembic gives you the most polished cinematic results, but it does take more time, more storage, and more effort for each shot. Choose Chaos Cloth. When you're working in live performance, virtual production, XR, or real time cinematics, you're using performance capture. Your characters are interactive, reacting live on set. You need real time responsiveness over perfect repeatability. With Chaos, the cloth is simulated on the fly, so it responds to the motion in the engine. You set it up once and it works across any animation. No need to resimulate every time. Ask yourself before you start, is your scene pre rendered or is it interactive? Do you need repeatable results or are you okay with natural variation? Repeatable equals alembic. Dynamic variation equals chaos. How complex is the costume? You can mix both. You might use alembic for close ups or hero shots and use chaos cloth for crowd scenes or background characters. Or you may even have two versions of the same garment. One version for chaos for quick playback and iteration. One version for Alembic for final renders with higher quality. Chaos Cloth saves time in the long run, but you'll spend more time upfront configuring the data flow. Alembic takes more time per animation, but gives you that film quality simulation frame by frame. Final thoughts. So, which pipeline fits your project best? Think about your technical constraints, artistic goals, production timeline. And remember, you don't always have to choose just one. Use each where it makes the most sense. That's it for today. In the next session, we'll go into more advanced troubleshooting and look at more complex garment setups. Thanks so much for watching and have a great day.